Welcome all. This is Ashok Kumar Sarvepalli. In our series of mensuration, we just discussed about the up to 10 problems in this sheet. So our session started with introduction of mensuration, the formulas and how each and every formula came, and we discussed about 10 sums so far. This will be our final session of mensuration, where we will be discussing this 11th, 12th and 13th problem here in this notepad. Fine. Let us continue. The question is, the surface area of the two spheres are in the ratio 1:4. Find the ratio of their volumes. As I said already in the previous sessions, ratio is nothing but a comparison quantity. It is not the actual values. So we've given here the surface area are in the ratio 1:4 and you need to find the ratio of their volumes. To find the ratio of their volume, you need to find the ratio of their radii first. That we will be doing now. The given information is the surface area of the spheres. So you know the surface area of a sphere formula, right? So what it is basically is 4 pi r square. Is the surface area of a sphere, and volume of a sphere is 4 by 3 pi r cube. Fine. So two spheres are there. That is why the surface area of two spheres are in the ratio 1:4. So for the first sphere, we can say that it is 4 pi, let's r1 be the radius of the first sphere. And for the second sphere, you can say that 4 pi r2 square. So this ratio is given. Ratio is nothing but you just compare both the quantities. So divide S1 by S2. So you will have S1 by S2 is equal to, typically you can call it as R1 square by R2 square, cancelling it out, 4 pi and 4 pi. And here you will have this 1:4, 1 by 4. And you can say that R1 by R2 is equal to 1 by 2 when you take square root. You can plus or minus 1 by root, negative root cannot come. So R1:R2 is the ratio is 1:2. The question doesn't stop here. We just found the ratio of the radii. Now you need to find the ratio of the volumes. Fine. The volume of the first cube will be, first sphere will be 4 by 3 pi r1 cube. And the second one will be 4 by 3 pi r2 cube. So basically when you divide these two, you will get all these things stuff cancel. You will have r1 cube by r2 cube. R1 by r2, we don't have the exact values. We just have r1 by r2 equal to 1 by 2. So you can say that r1 by r2 the whole cube. So that means it is nothing but 1 by 2 the whole cube. 1 by 2 is nothing but r1 by r2, since these are ratios we already had here. Yeah. So 1 by 2 the whole cube, which will give me a 1 by 8. So the volumes are in the ratio. So the answer for this is V1 is to V2 is 1:8. Fine. So that is what we got, 1 by 8. Fine. We will move on to the next question. Now 12th question says that a cow is tethered in the middle of a field with a 14 feet long rope. Fine. So a 14 feet long rope, a cow is being tied in the middle of a field. If the cow grazes 100 square feet per day, fine, there are much square feet will be there. Then approximately what time will be taken by the cow to graze the whole field? Fine. So a cow is being tied in middle and it has some rope, and cow can graze like this, right? 14 means. So typically it forms a circle, right? Assume in a field you have a standing pole and it is tied, so it can move along. It can form a circle actually. A cow, it forms a circle when it grazes a field. So it is nothing but 14 feet long rope is a feet. So you need to find how much area the cow can graze. They have given that. First we can find the area. It's a circle typically. So it will be pi r square. So it will be 22 by 7 into 14 into 14. This is the area that the cow totally can graze completely. So totally grass is there, the cow can completely graze this area. And it is given that in a single day, if cow grazes 100 square feet per day, so how many days it will take? So that is nothing but the area, number of days, nothing but the actual area divided by 100. So you can simplify this for now. So it will be 2 times So I will say that 22 into 2 into 14 divided by 100 will give me the number of days, because 22 into 2 into 14 is the total area the cow can graze. So in a single day it can graze 100 square feet, means this will give me the number of days. So 22 into 2 into 14, so which is typically 22 into, what you call 28 divided by 100. So if we multiply 22 into 28, that is around 616. So cow can is capable of grazing 616 square feet totally, and per day it scores 100, means approximately in 6 days or 6.16 days it can graze the complete field. Fine. So I will repeat again. So here typically what you do is, a cow is tethered in the middle of a field with a 14 feet long rope. So a cow typically forms a circle. If someone is tied the cow in a rope, so cow rotate like a circle, right? Along the rope, around the rope. Yeah. So if the cow grazes 100 square feet per day, then approximately what time will be taken by the cow to graze the whole field? This is what the question. And we calculated it, the area the cow is capable of grazing, which is 22 into 2 by 14, and finally by 100, because 100 is the number of square feet, amount of square feet grazed per day. So the question is to find the number of days. It's approximately 6.16 days. Fine. The final question in this series of mensuration. Yeah. A man walked diagonally across a square plot. So I have a square plot. Okay. So you know that. So to reach a point to another point, he walked diagonally instead of walking along two sides. Approximately, the question is, approximately what was the person saved by not walking along the edges? Is that not walking along the edges? So here, the question typically says, yeah man, you have a square plot. Fine. Square plot will be like this. Treat as a square. And you're going to walk from the point where you're going to walk from here to here. There are two ways to reach here, right? Three ways totally. You can walk in a straight line like this, or you can go like this, or like this. Since it's a square going in this direction or this direction, both are same amount of distance. But this will be, obviously this will be the shortest distance. So the question is, how much distance, how much percentage is saved by walking in this path rather than going along the edges? That is what the question. These are the edges. Rather than going along the edges, he walked like this. So how much distance is saved by this path? So what you can do for this type of question, you can take the specific values of a square. That will be easier for you. So you can take the square of length 1 centimeter each. So if you walk along the diagonal, okay, if you walk along the edges, the distance covered, in this case, distance covered, if walked along the edges, is 1 plus 1, these two things, right? So this one and this one, so which is equal to 2 centimeter. I keep 10 centimeter. Yeah, everything is in centimeter. Now what is this distance will be? This distance will be, the diagonal distance is nothing but, it's a right angle triangle in a square. You can apply a Pythagoras theorem. So this will be 1 square plus 1 square root. So totally 1 plus 1 root 2 will be this distance. Some people will also know the diagonal of a square is root 2 times the length of the side. Yeah. So root 2 is the distance you walk. Root 2 is nothing but, you will be approximately 1.414. Fine. So the square distance is 2 and this is root 2. Typically what you have is, yeah. So this is 2 and this is root 2. So the question says, a man walked diagonally across a square plot. Approximately what was the person saved by not along the edges? They are not asking the absolute value. They are asking the percentage. So if you would have walked along the straight, that will be the original distance would have been 2 minus 1.414 is that you walked along the diagonal divided by where he started, 2. So this will be the percentage he saved actually. So the difference is nothing but, if you would have walked along the edges, it's been 2 minus 1.414 is the percentage difference. It will be around 2 minus 0.414 will be minus 1.414 0.586. All right, so it is 0.586 divided by 2. So it will be like 0.586 divided by 2, 0.293. So 0.293 into 100. Fine. So meaning 29.3 approximately, this is the percentage he is saved by walking along the diagonal. Yeah, if you have walked along the edges, you walked 2. If you walked along the diagonal, it's 1.414, which is nothing but 29.3% lesser than what you would have actually walked. So what you would have actually walked is 2, and the difference is 2 minus 1.414. Fine. So this is the thing. This is the question actually. So a man walked diagonally. Approximately what was the person saved by not along the edges? So if the edges it is 2, it is 1.414, which is 30% lesser, almost. So hope all these questions you enjoyed the series of mensuration. I will get back to you with some other topics which will explain the concepts in 1 or 2 sessions, and then we will discuss few problems. Thanks for watching.